Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at ventilators, and this is perhaps the last lecture on ventilators. In this video, we will look at hardware circuits for ventilators, specifically on the patient side, and the hardware sensor side of ventilator hardware, and the actuator side of the ventilator. Here is the typical block diagram of the hardware circuit of a ventilator. Note that these are the various sensors that are there: pressure sensor, volume sensor, flow sensor. It's useful to have sensor redundancy, multiple sensors. Why? Because it's a very critical function. If one sensor doesn't work, you must be able to capture from another sensor. Then this information is then used to control the inputs of the ventilators. You have this blender, which essentially works on the principle. What is the principle based on which? This essentially works on the Dalton's law of partial pressures. That has a typical display, and there is a microcontroller or microprocessor unit and a wireless communication system and an alarm system that is there, and then there are both the oxygen and air mixing and the ventilator hardware circuit, or the hardware, that is ventilators circuit, that is also there. You also need to maintain humidity. You need to maintain, there is such a thing called optimal humidity. Too much humidification can also be bad, because it might increase the chance of infection. Too less is also bad. So, humidity to be maintained within certain levels, and one-way valves are to be properly checked before. This is the patient circuit for this. So, there is the inspiratory arm. So, the green one is the oxygen and the red one is the carbon dioxide, right. So, there is a closed loop ventilator circuit. Recall this picture. So, what is this? This is PEEP. Recall this picture. What are the various values of pressure in this case? So, there is inspiration is happening through flow of gas, through fresh flow of gas through this one-way valve, and through expiration happens through the other one-way valve. Then this inspirated gas goes through a humidifier and then goes into the patient, right. And the expiratory arm, because this is a one-way valve, carbon dioxide cannot go inside, that is not possible. So, that is how it works. One-way valves are in two different directions. These are the sensors that are there in the ventilators. There are primary sensors and there are accessory sensors. Primary sensors essentially pressure, flow, volume and FiO2. Accessory sensors essentially have EtCO2, SpO2, temperature and humidity. Accessory does not mean optional. In some specific cases, it may be required. It is called accessory. It does not mean it is optional. There is a difference between saying optional or accessories, right. So, it must, and it, by the way, if you have many sensors also, it does not mean that it is it's a better system. Actually, your sensors should provide actionable info, otherwise there is no point in having many sensors also. Also, many people, sometimes students think that digital sensors are better and do not require calibration. Digital sensors also require time to time recalibration, something to keep in mind. Among actuators, there are two types of actuators. One is a piston based system, the other is a blower based system. The piston based system can be divided into two types, and a reciprocating cylinder type or the solenoid type, one way. The other one is a blower based system, which is a rotating motor based system. The other one is a solenoid valve, which is a one way and two way valves that are quite often used. These are the various types of this. Sometimes students think that one is better than another, piston is more effective, solenoid is more effective. Actually, both can be effective. Both piston and blower systems can be effective. And also, in many cases, these solenoids can be replaced with a P-type controller or proportional control. In both these cases, solenoids can be replaced with a P controller, and in many cases blowers can deliver accurate volumes with absolutely, I mean, with an excellent closed loop control, blower based systems can deliver relatively accurate volumes. Recall that volume is critical. If you have too much of it also, it can cause damage. So, with this we come to the end of this video. In this video we looked at ventilator hardware circuit, patient circuit and hardware sensor and hardware actuators. With this we also come to the end of week 9's video, I think. With this we come to the last part of ventilation. So, with this we complete the topic of ventilators. Thank you very much for your attention.